All right, we're up and running. So appreciate that you guys are connected. I just want to talk to you about some things regarding this software. Yeah, first of all, I can have my camera on, but I usually have so many things to show that I'm going to share my screen, which is what I usually do. So the first thing I have to tell you about is when you move your mouse on your screen, you're going to see a couple menus appear. Toward the top, there's a bar, and on that bar, you'll see a microphone and a camera, among other things. And if there's a line, right now I muted all of you because this software really, you know, like I can pick up every noise you guys make. Okay, and in fact, okay. So anyway, you can unmute it anytime you want to speak. Just click on that crossed out mic, and you'll be up and running and ask your questions. If you want to mute your camera, stop your camera, you can in the same way. If you look at the top, there's a camera. I'd appreciate it if you left it on, but it's a, you know, you want to, you can. Then if you move your mouse, there's a bar on the left of the screen. And way on the top of that bar, there's this blue like text box. I would urge you to click on that because that opens up a chat window. And the chat window is another option for you to communicate with me if you want. Okay. All right, so then I wanted to show you, I wanted to show you something concerning our website. Okay, so I'm going to go to that.
Is this going to be 50 minutes like a normal class would be?
Yes.
Okay.
I mean, we can go beyond that, but that's usually what I'll do. Yep.
Okay.
So anyway, on our website, if you look up here at the top left corner, you'll see that for lesson 1-1, there's that 1, 2, 3, 4 from the past. And then I already have a link up for the video from today. That's from the other section that occurred at 8 o'clock this morning. Welcome, Christian. And Sheila, I don't know if you heard me, but welcome to you too. So anyway, that's from the other section. So what I'm going to do when yours gets posted, I'm going to put an asterisk behind the 11:30 section. So if you want to see, this is what we did at 8 o'clock this morning, and your session will always have an asterisk on it. That's the way I'm going to differentiate between the two. So there's 828 up there in the corner. That's the video from the other class. Okay. I wanted to show you a couple other things on the website. When you go down, I didn't have time to do this yesterday. Welcome, Dakota. So when you go down, when you scroll down a little bit, you will see after the syllabus, there's this approximate course schedule. And then below that, there's this thing called core exercises. I'll just show you what that looks like. When you load that, it's a Word document. And here's what's in that. What's in that is literally all the assignments for the year. So you can see right here is the, I mean, that's the 1-1 assignment. I didn't tell you that, but anyway, those are the minimum required, okay? And that goes all the way down through 5 chapters, which is the goal for this course. Welcome to a number of you. I'm sorry, we're in session already. Taylor, glad to have you along. Some of you missed this because I covered it at the beginning, and that is when you move your mouse, you will notice a couple things happen. You will notice that you'll get a menu for a black bar appears on the top, and you can mute yourself with that microphone. You can get rid of your video by clicking on the camera. I'd personally like you to keep your video up, but the muting, you would be surprised. We pick up everything. I can pick up you guys turning your page and your notebook and everything. So normally I would say, go keep that muted, and then when you want to talk, just click on it. Okay. The other one is way at the far left. There's another bar, and at the very top, there's this blue text box. Click on that, and it opens up the group chat window at the far right. That I would recommend, and then if you want to ask a question, but you don't want to do it audibly, you can do that too. Okay. So with that, we'll come. Let's see. So I've already basically covered this. You got all kinds of ways. Oh, and you can send me a text message anytime you want to. So for those of you who are not on live but are watching the video, you can still ask me questions using a text message. I will do my best. I've got questions like from 3 different sources. My eyes can't meet all of them at the same time, but I'll do my best. Okay. So the first lesson is actually called Graphs and Models. Okay. Thanks, Sheila, for the message. The actual lesson title for lesson 1.1 is Graphs and Models. But here's the weird thing. Okay, I've got 6 days to review all of pre-calculus. Okay, as you know, that was a full semester of teaching. So, even though the title of that, so I'm going to try to hit the high points in what I present to you. And today I'm going to be presenting functions primarily, which graphs goes into, but so you might notice a little bit of a non-perfect match there. Okay. So today's topic, we're gonna, these are all really important things for calculus, introduction to functions. I guess we're going to take a little side trip here, and that is that if you, I'm going to go to this link. I had told you I have a totally separate, I have another website, and I'm going to just show you what it looks like. At least I was going to. Taking a little while to load here. Oh yeah, so on that website, one of the lessons is a preview of calculus. So if you want to, I mean, this just shows you how complex it is. That what I did is it's an outline approach of kind of all the topics in pre-calculus. And if you want to go back, it's another way you can review. Also, on this independent website, you'll see there's a section at the end called Check Concepts. You don't have to do that. It's totally optional. And there is a thing, there's 5 questions here that it gives you a grade on, but it doesn't record anything. So you have nothing to lose. It's kind of a recall. So when you click the grade me button, it tells you how did I do? Am I up to it? And it doesn't tell you what's wrong. So if you get 4 out of 5, you can poke around until you get them all right. So anyway, that's available. Go back to our website. All right. So the first thing I just want to mention, 2 guys that kind of are on the honor roll for functions. The guy on the left is Gottfried Leibniz, German. And he had a lot to do with starting the concept of a function. And Leonhard Euler on the right from Switzerland, they both had, by the way, the guy on the left, Leibniz, is one of the two discoverers of calculus. Somebody want to volunteer, maybe? Who's the other discoverer of calculus?
Wasn't it Isaac Newton?
Yep, that is correct. Very good. So anyway, on we go. Function notation, I'm assuming everybody is pretty up on that. F of x notation equals x squared. And I like the way this says that the x is really what? Plug in whatever you want, plug input anything you want into that, and then the output can be calculated. So for example, what is f of 3? It should be 9. So when you plug in a 3, the output is 9. The point 3 comma 9. What is f of negative 1? 1. Okay. So anyway, Euler is one of the first guys to use that notation, and it's very big in our course. Okay, so I don't normally just use slides like this, but this is a pretty good introduction to this particular one. So, a relation. A relation is some kind of an equation, and the rule is any set of ordered pairs at all qualify as a relation. So in other words, this sweetheart is wide open. Anything works. On the other hand, when we go to a function, it doesn't say this, but in a function, it's a lot like two of us lined up to go get some milk. We both buy the same gallon of milk exactly, whole milk. The first person through gets charged $1.95. The second person through gets charged $10. Of course, we would never stand for that because on the same day, of course, they have to charge the same amount for each item. Well, that's the way a function works. A function says when you give me an x, there is only one result that can happen. Now, all the things that, so I guess let's go to the next slide here. So here we can see all of the things you might plug in are the x's, all of the answers are the y's. What's important is the arrow from each x only goes to one particular y. So here's another way to look. I need all of you to be able to tell if something is a function or not. Now, one way, you probably remember the vertical line test. So when you have a graph, you can do it. But you should be able to do it by looking at a set of ordered pairs also. So if you look at part A here, those ordered pairs do represent a function. The reason? Well, do you notice there's no repeat x value? No x value in those 4 points is the same. So the idea that when you plug in an x, you only get one y out is easily followed. So that's a function. But in part B, that is not a function because notice we have 2 points that begin with an x value of -1, and they don't have the same answer. That's a violation of what a function says. So for that, we have to say, no, that is not a function. All of you, we've talked about this already. Function notation, this f of, is very valuable because you can plug in anything you want. You can say, what's f of 10? What's f of 3? What's f of -9? What's f of triangle? You can plug in anything in place of x. So we're going to do some of that now. So here we have a function, x squared minus 3x minus 1. Find f of -2. So you all know how to do this. Plug in -2 every time an x appears, crank out the calculation, and it turns out to be none. And so notice the ordered pair up here. That's all that's saying is, yeah, when you plug in a -2, out comes a 9. And of course, that's the point that can be graphed. Here's another one. This time the function is 4 times x minus x squared. What's f of x plus 2? So now we plug in an x plus 2 every time an x appears in the formula. And now we're not going to get a numerical answer. As you can see, they multiplied out the distributive property. Then they did the x plus 2 times x plus 2. Remember, that comes up with a trinomial. And then you finally gather like terms. The best we can do is 4 minus x squared. So that ordered pair on the bottom results where we're saying, hey, when you plug in an x plus 2, out comes a 4 minus x squared. So when we talk about domain of a function, we mean what values of x can we plug in? So this one, f of x equals 3x plus 5. Is there anything you could plug in that we would not be able to calculate on? No. Any number that you could plug in, x equals 2, x equals 7, x equals -8, x equals the square root of 5. Doesn't matter. We can operate. So the domain there is no restriction, all real numbers. So sometimes they ask you to find the domain. So on this function, the square root of x minus 3, is there any value of x you could not calculate on? And the problem here is the square root. You, at the moment, with by the way, we're assuming we're going to be working for most of the time with real numbers. So we can't take square roots of negative numbers in the real number system. Therefore, any value of x that would make that thing underneath negative would mess it up. By the way, 3 is okay. 3 minus 3 is 0. The square root of 0 is 0. So that's fine. But 2 for x, not going to work. 1, no. Any negative? So in other words, x has to be 3 or bigger. So the domain on that one, they write it this way at the bottom. All x such that x is larger than or equal to 3. That's a way of saying any number that's 3 or above is fine. So here's one that I made up, 3x minus 3 on the top here, our function. What's f of -3? Plug in -3. -3 times 3 is -9. -9, subtract 3, -12. That's good, no problem. How about f of x plus 1? Plug in for x and x plus 1. Crank it out, 3x plus 3 minus 3. And the best you can simplify it down to 3x. So when you plug in an x plus 1, out comes a 3x. F of triangle. Plug in a triangle wherever there's an x. 3 triangle minus 3. Sometimes I'll do silly, like f of pickle. Just to emphasize the fact that, hey, whatever they've told you to find f of, plug it in and write the result. How about the domain on this one? X plus 2 over x squared minus 1. What's another thing we have to worry about besides square roots of negatives? In division, you can never, ever divide by 0. So what would create a 0 denominator in this expression? And there are two things, right? You can't have 1 and you can't have -1. because both of them would result in a 0 on the bottom. So here, we just say, hey, anything except 1 and -1. Here's how it's written at the bottom here. All x such that x is not equal to plus or minus 1. So now we're going to get into what's called a difference quotient. Okay, let me, I'll tell you what, I'm going to erase and we'll kind of go through this. We'll do this part over again. So we've got a graph here, and we have a angled line here, along with a vertical and horizontal underneath it. And I want to get my pencil here and do some drawing. So take 2 points on the line, 2 points on that angled line. Do you know how to find the slope between those 2 points? Of course you do. The slope formula. You might remember it like it is over here on the right. Change in y over change in x. You might have learned delta y over delta x of the second y minus the first y over the second x minus the first x. Well, this would be our first point here. And if we use just generic points, what are the coordinates of this point? Well, so if we just say that's x, then this point is x, comma, and in function notation, the answer is f of x. Then if we move over to the right, h, let's say that distance is h, then this coordinate is x plus h, and the answer would be f of x plus h. Now, put those into the slope formula, and what do you get? I forgot my second parenthesis. So take the second y coordinate minus the first y coordinate and divide it by the different, the x's. What's x plus h minus x? H. So this thing in the box is basically just a slope formula. Okay. More importantly, you're going to hear it called a difference quotient. A difference quotient, okay? And one of the things I'd like to spend time on today is how do you find some common difference quotients? All right. So here's the first one we're going to do. And I'm going to come over to the right here and we'll start over so I can do this live. So what was this one? 2x plus 1. Okay, so if we start with that function, and then the book, or I say, find the difference quotient. What they're saying is, all right, we need to find this thing. Using that same notation that we used just a few seconds ago on the previous. Made a little mess there. So you need to really pretty much memorize this, okay? You may have it already, but this is called a difference quotient. Okay, so how do we apply that to this problem? Well, obviously, I need to first, I got to find f of x plus h. So let's do that. What is f of x plus h in this particular problem? Definition from the function is up here on the top. Plug in an x plus h in place of x. Does that look right? So when I plugged in an x plus h, what's 2 times x plus h? Distributive property says 2x plus 2h. right? Okay. So now let's put the pieces in. We got that thing. So we gotta do this box thing. F of x plus h. Now subtract the original function. By the way, those parentheses are pretty important. And divide by h. Okay? So what happens on the numerator? 2x, subtract 2x, there, that's going to be gone. 2h is going to be left. And then you're going to have a 1 minus a 1. So the 1's gone. So we're left down, now we're down to this part. We can cancel the h's. What is the difference quotient for this function? 2. Maybe I went a little too quick. Anyway, anybody have any questions on that part? Okay, I'm going to move. So here, let's do one with a square in it. The blue here, x squared minus 7. And again, I'm going to shove over to the right here. Well, we got to find a spot where I have space. Okay, let's go way over here. F of x equals x squared minus 7. Find the difference quotient. So that means I need to do this one more time. I'm going to write it out. So I need to find that expression in the box for this function. All right, so the first thing I got to do is I got to figure out what's f of x plus h. Well, plug in an x plus h wherever there's an x. Okay. And of course we can square that. What is that? X. Go ahead. What were you saying? Oh, okay. My mistake. Does everybody agree with that? If you take x plus h and square it, you would get that trinomial. Okay, so now that we have f of x plus h, now let's do this whole box expression. So f of x plus h now subtract the original function. So subtract what you began with way up on the top. Divide by h. All right, in this case, if you simplify the numerator, what happens? Well, if you look ahead, you got an x squared, and over here you have a minus x squared, so x squared is gone. You've got a minus 7 and subtract a minus 7, so those are gone. So what you're left with is okay. Can we simplify that? With a little factoring, we can take an h out of the top, right? And then, of course, the last step is we can cancel the h's. So what is the difference quotient for this one? 2x plus h. Questions? Comments? So there's nothing really very new here. It's just maybe the terminology, and these difference quotients are huge for how we begin Calculus 1. Okay. Yeah, I'll just show you. I mean, sometimes they get longer. Like if you look at this function, 2x squared minus 3x plus 2, find the difference quotient. So first I had to horse around and find f of x plus h. You can notice I did that. I came up with what's above this green line after bringing everything together. 2x squared plus 4x plus 2h squared minus 3x minus 3h plus 2. From that, I subtracted the original function, and this is an interesting way to subtract. You notice I put the original function right below it in blue, and I purposely lined up the terms that match up. So we're subtracting 2x squared, subtracting 3x, we're subtracting 2x. And then you can see what remains is just, the part that's left there, 4xh plus 2h squared minus 3h all over h. And of course, we can what? Factor the h out. And we have our difference quotient. Okay, so those can get a little bit long when you have a longer expression. I'm going to do this one with you. Okay, let's take a quotient, and we need to find the difference quotient for this. Except instead of using, let's change the problem into an x problem, just to make it a little bit more direct. So in other words, let's say f of x equals 1 over x minus 2. Okay, find the difference quotient. Now I'm not going to write it down this time. You got it? F of x plus h minus f of x all divided by h. So in order to begin, I need to find that before I can do anything. So wherever there's an x, plug in an x plus h. Okay, so now take that thing and do what? Subtract the original function and divide by h. Now, by the way, you're never done with these difference quotients until you can get rid of that h on the bottom. So what are we going to do? How are we going to proceed here? How can I simplify this so that eventually this h can get canceled? Well, what do you do with two fractions that don't have the same denominator? Well, you get a common denominator, right? So let's see, I'll change to a different color here. Let's change to a blue. Okay, so I need what? An x plus x minus 2. So I'm going to multiply top and bottom of that fraction by x minus 2. And this one, I need an x plus h minus 2. That'll give me two fractions that have the common denominator, x minus 2 times x plus h minus 2. Okay, so that first fraction is going to be what? X minus 2? I mean, we're going to have the common denominator, so let me write that in. X plus h minus 2 times x minus 2. And the first numerator, x minus 2 times 1 is x minus 2. Minus, and then over here we got a minus this thing. Because again, we're multiplying by 1. All right, now that whole thing is divided by h. Well, maybe I confused you with that, so let me just put it all over h. So there's where my difference quotient sits right now. Now, can I do anything with that thing on the top? Yeah, they got a common denominator. So can I bring that together? On the numerator, We have x, and then we later subtract x. Okay, so that's gone. X's are gone. -2 minus a -2, the -2's are gone. So all we have left on the top is a minus h, right? Because we're subtracting that. And on the bottom, we have our common denominator. And then on the bottom, we have divided by h. Isn't that the same as if you're dividing by something, can't we change that into multiplication by its reciprocal? Yep. And so I got some space here to finish this off. So you can now see the h's cancel. And what's left? On top, we have a -1. And on the bottom, we have x plus h minus 2 and x minus 2. There's your difference.
How did you get to the minus h over the two multiplications?
I got there by just to the left of it over here. X minus 2 subtracting the quantity x plus h minus 2. What's x minus x? X is gone.
Oh, okay, so you just solved that
I
fraction.
just simplified that numerator.
Okay.
Yeah. And then you got to be careful, guys, when you cancel the h's, you sometimes forget about the negative. We still have that negative on the top. So this thing in the circle would be the difference quotient. Any other comments or questions?
So do you need to simplify that? Oh, I'm sorry.
You mean simplified? You mean multiply out the denominator?
Yeah, or do you just care that we cancel out the h? Is that?
I would be fine with the denominator staying factored. Could you multiply it out? Certainly.
Okay.
But if you do it, of course, you got another chance to goof up. So I would be happy with that answer. There were two people. Is that what the other? Go ahead.
How did you get the reciprocal of 1 over h? Like.
Okay.
Yeah.
So when you're dividing by h, isn't that the same as multiplying by 1 over h? So how do you change? When you do a division of fractions problem, right? If I ask you to do 8 divided by 3. Isn't that the same as 8 times 1/3?
Yeah.
Well, that's the principle I used. If I divide by h, that's the same as multiplying by 1 over h.
Okay.
Okay?
Yep.
Thanks for asking your question. Is everybody okay with this? So let's do a square root problem. So at the top in blue, you can see our function is square root of x minus 3. And by the way, why do you think I have comma x is greater than or equal to 3? Are you guys, you're up on that, right?
Yeah, the domain.
Yeah, that's just the domain, right? So why can't I have x be less than 3?
It would be an imaginary number.
Right. And right now we only want to deal with reals. That's correct. All right. So let's do a difference quotient. So you have to plug in the square root of x minus 3 wherever there was. I'm sorry. You have to plug in x plus h wherever there was an x before. And that gives you this thing. Square root of x plus h minus 3 minus the original function all over h. How in the world? So this part over here on the right is that's my next step. Okay. So how do I get h to cancel? And the answer is the only way out of it is to use what's called a conjugate. What's a conjugate? A conjugate is a factor that when you multiply it here, look at the top of the page here. You guys all know that the quantity a plus b times a minus b is what? A squared minus b squared. Do you remember that? The difference of two squares? Because what would the two middle terms be? Plus ba minus ba, and they annihilate each other. That's the kind of thing you need to do here. Otherwise, you're going to have a middle term with roots. So if I take the same terms I have with the opposite sign in between, what's going to happen when I multiply those? I'm going to get the difference of two squares. And what happens when you take the square root times itself? You get that thing. When you square a square root, you don't have a square root anymore. So you got that, and then on the end, you get the difference of two. You get x square root of x minus 3 times the square root of x minus 3. So do you see how I got rid of the roots, which is absolutely necessary? So that's the technique. It's called the conjugate method. C-O-N-J-U-G-A-T-E. Here, I'll write it out. Okay. Well, now, can I simplify this one in the next step? Yeah, because x, take away x, goodbye x, h is left, and minus 3's get rid of each other. On the bottom, I still have a mess, but the good news is now I can cancel the h's.
I have a question.
Yeah.
Before the step where you have conjugate next to it and you circled in blue and you're multiplying the top and bottom by the reciprocal.
No, not by the reciprocal.
I mean, like,
by the conjugate, yes.
Yeah.
Yes.
So you're trying to get down the bottom with h, so then you can cancel out the top to get rid of the h's?
That's the ultimate goal, yes.
Okay.
So way at the bottom, you may not like this, but that's your conjugate down here. 1 over, and it's not beautifully simple, but there it is. That's it. That is the difference quotient. Sorry, the penmanship's not the greatest, but anybody have any comments or questions? Okay, so, and now I you know, there's never enough time to do everything. Last time, I wish I'd have had more time, but I didn't. I wanted to show you what kind of, you know, what am I looking for on homework? So I'm going to show you, this is my homework for this section. Let me make it bigger, and I want to go back to the beginning. Okay, so here's my homework paper, and it happened to be 39 to 55 odds. Okay, so number 39, if we go and look at the directions, I'm going in the book to number 39 here, that section where 39 is. Oops. So you can see the directions here. Using intercepts and symmetry to sketch a graph, in exercises 39 to 56, find any intercepts and test for symmetry. Then sketch the graph of the equation. Okay, 39, y equals 2 minus 3x. So you can see I wrote out the function. How do you find intercepts? Well, a y-intercept has got to have an x-coordinate of 0, right? 0 comma something. So you plug in 0 for x, calculate, you get an answer of 2. So the y-intercept is 0 comma 2. Anyway, then you go ahead and find the x-intercept. Now, Symmetry, well, this is a straight line. How do you know that? Because everything's to the first power, so we're not going to really have any symmetry here. And then you just kind of sketch it out. So some kind of a detail, something like that, is what we're looking for on homework. So, okay. I just wanted to give you a rough look at that. And then on the website, you've got the schedule for the classes. And you remember I showed you the core exercises? So what I do during the lessons is I break down the core exercises by chapter. So here are the same things you saw a few minutes ago, but here are just the chapter 1 assignments. I know I didn't tell you this yesterday, but now we can see specifically which ones do I want you to do.
So 1.1 is the homework that'd be due tomorrow if you were to collect it or not?
Actually, it was really supposed to be looked at for today, but that's okay.
So do you want 1.1 and 1.2 due for tomorrow, or just 1.1?
So the next one I'd like you to look at is 1.2. So
Okay.
for tomorrow, you want to, hopefully you may not have done those exact problems on 1.1, that's fine. But for 1.2, these are the ones I'd like you to do. 1.2, let's quickly take a look. Actually, I'm a little bit off. This is kind of what I was going through with you today. Right? Linear models and rates of change. And look what they have in the middle of the page, slope. So things related to slope. That's really all a difference quotient is, right?
Yeah.
Is a slope. So in a way, I kind of even, like I said, I got to pick and choose on chapter 1. And so this is really your lesson. And once again, your assignment, it's in the wrong place here. Your assignment would be number 5, number 11, number 17, number 19, 25 to 29, the odds, etc.
So 1.1, do you want us to do all of those or just 39 through 55 odd?
I wanted you to do all of them. I just showed you some of them. But
Okay.
yeah, if you really want to make sure, you should go back and make sure you can handle those. A reminder, I don't know, I think I told you this, but the odd number exercises do have solutions in the back of the book. However, you know how it is with algebra. There's probably, 10, 20 ways of writing the answer. So you may have, it's not perfect. You go to the back and look, you may have to do some transformation to prove to yourself that they really are identical. Questions? I appreciate you guys all hanging in there, and at least it was our first experience with this technique. I appreciate the fact that you guys ask questions. That's good. About 5 minutes after class is over, I will have posted this video also. And again, this 11:30 section will have an asterisk by it. Well, thank you. Have a good rest of your day. Stay dry. Sounds like we're going to get rain.
Thank you, Dr. Boileau.
You're welcome.